everybody. One issue which is, I think now we understand it more, even though it was important early in the beginning, is that the protocol security itself is getting more interesting, and it's always the case. So we are fortunate to have actually the Ethereum Foundation, one of the key researcher, Antoine, presented issues related to security. How do we deal with security at the protocol level?
Okay. Thank you. So I'm just going to start off. Yeah, thank you for being here, everyone. This is protocol security. But before starting, I'm just going to introduce myself a bit about my background, who I am, and how I came into the field. So I started in Web2 security about, let's say, 2 years ago. I did 1 year doing vulnerability research and vulnerability analysis, static analysis, and also dynamic analysis, so SAST and DSAT, mostly on Docker container and Docker images. Then I transitioned doing formal verification using the Kafka language for about 6 months at a company called Formal Land. They're based in Paris and they're also blockchain based. There I did the verification of the SUI type checker. And then I started also in parallel doing some Web3 security contests on various platforms such as Code Arena and Sherlock, Cantina, and that's pretty much what my background is right now. And then after that, I joined the Ethereum Foundation about 6 months ago, and now I do just vulnerability research for them. I give talks, as is today. I mostly focus on the execution layer side of things, but I'm starting to pick up the CL side, which is the consensus layer. So I'm just going to explain as well who we are as the foundation and what do we do, and especially focus on our team. So we're a team of about 10 people. We have currently 8 people full-time, and we're just onboarding a new AI security researcher as well, and we have a few people part-time. Some of them are working across different teams, so we have someone working from the Geth team, but also on the security team. We have someone working on cryptography team and also on the security team. And these are, basically just core members of the security team as well. What we do fuzzing. We have public fuzzing and private fuzzing. I'm going to be explaining a bit why we have some private fuzzers as well and what kind of fuzzing do we do. We also perform manual reviews, mostly on the execution layer, the consensus layer, and the different EIPs that are being included before every fork. And we also review the execution specs and also the consensus specs. And then the team, we have someone who leads the consensus specifications. We also do research on client diversity and ZK. We have a dedicated cryptography team as well, and a lot more things. But that's just the main thing that we do. So now I'm just going to explain what is protocol security. I'm sure most of you here know about smart contract security, but it's very different from protocol security. If you look at what do we expect and what do we search for in protocol security, we search for network level rules and consensus correctness, whereas in smart contract security, we look for app level logic and vulnerabilities. Examples that we find in smart contracts would be reentrancy, rounding issues, oracle manipulation. It could also be like broken access control and these kind of things. And these have an impact on individual contracts and the users that are using the contracts and the users that are using the platforms where these contracts basically are being interacted with. On the protocol security side, we have different type of bugs, and some of them are SSZ and RLP round trip errors. So these are different names for encoding and decoding, and we also have invalid state routes and EVM divergence. And this really affects the entire network safety and not just one smart contract or one application. Tools that we use in smart contract would be Slither, just traditional audits through competitions or just private audits. We could also use formal verification on the protocol security side. On at least at the Ethereum Foundation, we use Hive. We do also some fuzzing. It could also be done for smart contract security, but we focus very much on that. We do manual code review, and we also try to do audits now on different platforms. Formal verification can also be applied to protocol security and just infrastructure security as general. But this is, the main idea, so it's very different. For example, the RLP and the SSZ, so it's different type of encoding that are implemented in the different clients that have been used by the Ethereum. So we have the EL side and the CL side, which is the execution layer and the consensus layer. On the execution layer, the RLP process the encoding of blocks, of transactions, of receipts, and state trees, and some different things as well, but just that's the main things. And on the CL side, it processed the encoding of beacon blocks, attestation, and validators data. And it's also processed the decoding part, and these issues can arise. For example, if you have two clients with a different implementation, some might be implementing it one way and the other one would be implementing it another way in different languages. And the type of errors that you can get on the EL side, for example, would be leading zeros. There can be some different encodings if you have leading zeros. Also, if you process empty strings versus empty lists, it's a different type of thing. So this could cause issues and consensus divergence, basically. On the CL side would mainly be miracleization, which is, it could be like, using the wrong number of leaves. It could be using hashing in a different order than what is expected by all clients. And so, if you do not respect these rules across all clients, you could cause, a client split, basically. These rules are defined in the specifications on the EL side, but also for the CL side. Now I'm just going to explain what is the Ethereum architecture as of today. So as of today, this is basically the workflow that happens when you interact with an app or you want to send a transaction through a wallet. Let's say you're a wallet, you want to send some money to another wallet. What would happen behind the hood is you would make a JSON RPC call to one of the RPC providers like Infura or Alchemy or whatever it is. That would go on the execution layer and it would process your contracts, write a new payload, and just give you like a new state route. And then every 12 seconds, the consensus layer would ask the execution layer, do you have like some data to provide to me? So it would give it a new fork choice, so a new head to follow, and it would ask for the payload that has been built. And the interaction through these two is basically using the engine API. So this is how the execution layer and the consensus layer communicates. And then it's just being propagated and validated through all the different CL nodes, and it processes the block. And then you have the finals chain, and then it goes on again with the new transactions and new basically interactions with the blockchain Ethereum. One thing to note is, especially for Ethereum, and it's very important, is client diversity. So these are the different clients and the major clients that have been basically implemented for Ethereum. So on the execution layer, we have about 40% being used by Geth, about 40% as well for Nethermind, about 15% for Bezu, and then some other clients which totaled about 10%. And for the CL side, we have Lighthouse, which is the client that Sigma Prime is developing for now a few years, Prism, TakeU, Nimbus, and some others. And internally, we use different type of security. So I mentioned fuzzers. We have tools from ETH Panda Ops, which is our DevOps team. We used Antithesis for the merge, and that has been very helpful to basically do some testing, which would be very hard to trigger by normal fuzzing, and you can deterministically fuzz and just reproduce hard cases. Curtis as well, we use it, and we use also Hive. I'm just going to give a few examples of that. This is a list of some of the fuzzers that are public, and some is still private. I think Nosy is private. On the execution layer, we have Fuzzy VM and TXFuzz, which are tools that have been developed by someone of our team called Marius. He's also a core maintainer of Go Ethereum. And we have Go EVM Lab, which has been developed by someone called Martin, which has since then left the EF. We also have private fuzzers. For the cryptography side, we have a KZG fuzzer written by Justin, which is the senior member of the team, and also he is the lead of the consensus specifications. We also have private fuzzers on that, and on the consensus layer, then it's mostly private fuzzers. Now, you might be wondering, why are these fuzzers private? And so the reason behind that is just security. We want to be battle testing and using our fuzzers before state actors or malicious actors would use them. And we have specific techniques that we don't want to reveal to the public. This is one of the tool that ETH Ops has created, which is called the lab. And every node can willingly use XAT2, which is a data collection framework that has been also developed by PandaOps. And then all the nodes would then just appear on the map, and you could see in real time what slot we are, what step basically we are, and in the whole Ethereum cycle. Another tool, which is Dora, the Explorer. It's a blockchain explorer basically, but with a specific design that is very simple to use, and we mostly use it to monitor our validators' performance. You could just check anything on the network health. We have it for every testnet that we have, but also for mainnet, if I'm not wrong. And we also do DevNet before every fork. So for each DevNet that we have, we can use the Blockchain Explorer to just monitor how things are going. The last tool is Hive, which is a regression framework and also an integration testing security tool. So it uses the execution layer specification, and it checks across all clients if these specifications are still passing after updates or anything to detect bugs in clients. And this is like one of the example for Fusaka, but we have like many of them. I think across the old testing repository, we have about 46,000 tests. One other approach that we have is differential fuzzing. We have the EIPs are included in every fork and the specifications linked to them. And for each of the major clients, so Lighthouse, which is in Rust, Prism in Golang, Teku in Java, and Nimbus in Nim, and the other ones in various languages, each have their own implementation of this EIP, and they do things very differently, which can make it hard to manual review because you might see one code performing such a thing, but on the other hand, on another client, you might be seeing a completely different thing that is supposed to do the same thing. So one way to easily process that is we would target a specific function and just look at the results of each client produce. And for example, Lighthouse will produce a result, Teku will produce another one, and then we'll look at the different results of each and every client. And if they have the same results, then everything is good, all clients agree, and all clients will process it the same way. So we can keep on fuzzing. If we have different results, it might crash or just log it that we have some kind of differences. And then we also want to log the seed for the input that has been used for the input generation. It's either fully random or semi-random. We can define structs and then use crates in Rust, you can use crate like arbitrary, which allows you to build arbitrary stocks. And then we would log the seed to allow reproducibility. So we can just reproduce the case a lot of times to make sure that it's not just a one-time issue in our fuzzer, but it's an actual issue in one of the clients or multiple clients. What is the next thing that we do when we have found a bug then? So you might be wondering if we receive a bug on the bug bounty program, or if one of our members discover a bug in one of the clients, what do we do? We have dedicated client team chats, and one thing we would do is easily, if it's sent from the bug bounty program, we would discuss it internally usually, and then just make some kind of triaging if it's a false positive or not. Our team lead, Frederick, is usually the only one who received the submissions from the bug bounty program, but we also have someone from the cryptography team who has access to it. And then he would share that within our own chat, and we would discuss it. If it's a bug found by one of the members of our team, we would directly send it to the dedicated team chats, and we use Signal for that to ensure the highest level of privacy on messaging applications. What would then happen is that we have either the EL or the CL clients, and they would see the report that has been sent to them, and then we would be discussing it. If the report is valid to them or invalid, they might have made a specific choice in their code for either performance reasons or security reasons. They might be implementing it this way for a specific reason or not. And so they will decide if they want to implement a fix, if they want to make a new release, or just deny it. We, as the Ethereum Foundation, we do not own any of the clients. We are just supporting them, and just, giving, if we have any bug, giving them the insight that this bug could be in their client. During the fix, it can either be public if it's a small thing, if it's quite an impactful bug, like a high or a medium vulnerability, depending on the impact that it could have on the network. It will usually be hidden in various different ways. So you won't probably know, like, if there's a new release, they would not say, oh, there's a bug in the other previous versions. Otherwise, malicious actors could just start targeting the mainnet network, and we do not want that. Regarding that, actually, Geth at some point disclosed early on one of the vulnerabilities, and 12 hours later, some malicious actors started impacting the mainnet. They've done some reverse engineering for the past 12 hours, trying to find what was the bug, and then how to craft a specific transaction to impact the network. As a result, the Ethereum security overall is improved, and then we can repeat on reviewing, fuzzing, or just receiving continuous reports on the bug bounty program. Nowadays, Geth, I think, does disclose their release if there was any bug after 5 to 8 weeks to avoid these kind of issues, to let anyone take the time to upgrade their node and just change it to the latest versions. We also discuss with major providers, just taking providers, for example, if there's been any bug found, we wouldn't give them more information than we give to the public. We would just send them a reminder like, oh, there's a new release, you should update to that. We also collaborate with other blockchains, basically. There are Geth forks, for example. So we have the Binance chain, we have the Base, OP, Polygon, and Mantle. These are big chains that are all a fork of Geth, except for Binance, which is a fork of OP, which is inherently a fork of Geth. But we do also communicate with them just to upgrade the release or just make some changes in any case, just like we would do with our own client teams. And the reason why we do that is just we want overall blockchain security and not just Ethereum security. We want to do this for the whole ecosystem. We have some kind of external security as well. So I mentioned the bug bounty program. Currently, it's capped at 250K for a critical, but it's being looked at by the Ethereum Foundation. We might want to bump that number up in the future. We think that having some kind of security, maybe some pledge from different layer ones or anything that is building on Ethereum's layer twos, to just pledge some kind of money to the Ethereum Foundation for a critical. Let's say you have a critical, and let's say we use $50 million as a bounty for a critical that could destroy Ethereum, like a Black Swan event. One thing we could do is we could ask major protocols to pledge $3 million, for example, if they have like 1 billion. It's not that much, to basically just protect Ethereum, because we are a foundation. We do not have, we do not own clients. We do not own Ethereum. We're just doing this for the public good. Also, we go through different platforms. So we've gone through Immunify for one of competition. We've gone through Cantina for the Pectra upgrade, and through Sherlock for the Fusaka upgrade. Now Glamsterdam will be coming in the next year, and we will probably choose another platform. We want to have some kind of diversity across different platforms for competitions. And then ideally, in the end, we'll just stick to one that have been the most easy to work with. We also have grants. We do some part of funding to the SEAL 911 initiative. We do not fund the whole thing, but we have made some funding to them. They do incident response, so I don't know if you're aware of what they are and who they are, but they've secured more than 75 millions on chain. If you have any hack or anything going on if you lose funds or something like that, you should contact them. They have a Telegram. They respond pretty quickly to big incidents. For example, for the balancer hack that happened like a few weeks ago, I'm pretty sure that we're reached out to for that kind of case. We fund some fuzzing grants. So we currently have someone in South Korea working on some fuzzing projects that we sponsor, and we also have been funding some formal verification projects and some more things as well, like the Ethereum protocol fellowships. I'll move on to some kind of bugs that have been found in different clients. I've mainly used Geth as an example because they have a public advisories on GitHub, so it's easily to just go there and find some bugs to present. But we also have a public disclosure repository. It wasn't really maintained in the past year, but I've picked up that task and I'm constantly updating it whenever we have a report on the bug bounty program, or if for competitions, for example, I'll just make a new report. This is a DOS that has been found, so it's a high vulnerability. It's in Go Ethereum, and so it would make the node crash or shut down immediately whenever a peer would maliciously send some public key, which was invalid, basically. The reason for that is Geth did not make a check on the elliptic curve. So the math that is being used behind this elliptic curve is just this equation, and it should be only valid if only points satisfying this equation make it valid. What happened is that an attacker could send a completely null public key using full zeros, and this point would not be on the curve. So when we try to compute the slope of that curve, we end up with dividing by 0, which is completely impossible, and this would cause a panic in the program. So the program crashes, and as a result, the node goes down. This is the fixed commits for this bug, so it's just a simple one, but we want to check that the point is on curve whenever we initiate the handshake, the decryption. And this is an example of how an EL could be represented. So you have multiple EL clients connected together via peer-to-peer, and we have one malicious client, let's say Nethermind, and they're connected to 3 Geth instances. They could just send some malicious public key to these Geth instances and automatically just crash the nodes. So all these red nodes would just go down, and that would be instantly. If you have something else, like you're spamming a node, for example, or it's not instant, it could have some kind of protections and just disconnect the peer. What is the impact of Geth DOS? So Geth is still, as of today, one of the most major clients that we have. It has a 41% share. So by that, it means that anyone, if they were running a mass attack on Ethereum, 41% of the network would be at risk. We could have slower transaction and slower block processing, and some RPC endpoints wouldn't be available. Like, let's say you want to send a transaction via MetaMask. If they're using a Geth node behind their RPC endpoint, then it would basically just crash or stall, or overall, these kind of attacks just leads to network instability. Another example of a bug that has been also found in Geth is also a peer-to-peer bug, and this one was pretty critical, almost. You could just, by sending a ping down a client as well, it will also crash. And the reason for that is whenever Geth received a ping, the peer-to-peer handler would spawn a Go routine. A Go routine is basically Go's way of creating a thread in the code. And so spamming these ping requests would just create an infinite amount of threads and overall cause an AOM, which is an out-of-memory issue. And here's a little example of what this could look like. The attacker node just spam pings the victim node, Every time it spawns a goal routine, which leads to resource exhaustion and eventually the crash of the node. Another bug, which is also in Geth, so this is a consensus vulnerability, it's not just a DOS. This is to me at least, the most critical kind of bugs that you can have in a client, because this means that the chain is forking away. Basically, it's like you have one client saying X and the other client saying Y, and so they disagree on the results, and eventually they start creating their own chain because they're not following what every other client is saying. So let's say you have a bug in a dominant client like Geth, the attacker sends a TX, Geth processes it the wrong way, and because it is a high majority client, it wins. In the past, Geth used to have more than 70% of the network, so obviously now it's helpful that we have more client diversity, because you need to have bugs in multiple clients at the same time to have a real risk on Ethereum. But let's say just Geth has the majority and the rest of the clients doesn't have. Even though the rest of the clients are right, the minority is going to lose, and Geth is going to pick up the new canonical chain, which is the chain that everyone should use. And then as a result, we're following the wrong chain. What does that mean? Is that we have potentially invalid balances, potentially invalid state roots. This could cause a lot of issues in just Ethereum in general. Just as an example of what a fork choice is, so you have the chain of block, which is the canonical chain, so all clients agree to that one. Sometimes two blocks are proposed at the same time, so you would have a kind of reorg, which is you follow a different chain for just like 2 seconds, and then you reorg back to the canonical chain, and then you have the minority chain, which is valid, which are followed by other clients. But because the majority chain wins with the bug, it's the one that is followed by everyone. And so the validators running on the wrong chain essentially will get slashed for processing the right chain information. So the purpose behind client diversity is that we have 66% to reach finality. So in a network, if you have more than 33% of the validators that are down, it prevents finalization. And finalization is when the block is fully produced, fully tested, and then you can't just go back in time, so it just follows the chain. And if you start having some bugs, it forks to its own chain, and you can't return without slashing your validators. If you have any questions, please do let me know. It's been a bit short. I think I've gone a bit too far on my speaking. But if you have any questions, please do let me know. I've linked some links for the bug bounty program for our team and the responsibilities of the protocol security. I've linked the Go Ethereum advisories if you want to have a look at the bugs that are shown there, and also the public disclosure, which contains all the bugs basically that have been found from Ethereum day one. And if you have any kind of urgencies, you can always contact SEAL 911 or just use the Telegram. I think it's the easiest way to reach out to them. And they would be pretty happy to help. They're doing this for free, basically, in their free time. They're just funded by a lot of different organizations, including the Ethereum Foundation. Thank you for attending this, and here are my socials.
Yeah. Hello, thank you very much for your speech. You mentioned in the first part that you were working with formal lens and using COC and formal verification. What do you think about the future of this technique currently? Are they applicable in your work? And what kinds of formal verification technique are you using now? Thank you.
Thank you for your question. At the Ethereum Foundation, I'm not using any kind of formal verification techniques. But we funded a grant actually for Formal Land as well for them to formally verify the REVM, which is the EVM implementation written in Rust. I think formal verification is extremely useful. However, it's only useful if the specification is correct. So if you have the wrong specification, you could still verify that it's basically following the specification. But if your specification has a bug, it won't find it. I think formal verification has its advantages. However, it's pretty complex and it's super lengthy to put in place, at least using Coq. For example, the number that I had in mind is if we had 1,000 lines to verify, we'd have to write about 5 times that to basically just formally verify it. So if you have 1,000 lines of Rust, you would have to write about 5,000 lines of Coq to formally verify it. So let's say the project took, I don't know, 2 years to do it. To formally verify it would take you about 10 years. Considering like you're an expert in Coq and you don't have any issues with translating things. Also, it can be pretty complex if you start having some very difficult types and not just just an integer or a list or something like that. If you have custom types, you want to basically just define them in Coq, and it can be pretty difficult. So I think formal verification has its future, but it's a different business than just fuzzing or manual reviews. Thank you for your question. Does anyone else have another question?
What policies does EF have if some critical bug is found so that it is deployed before it gets exploited? Does it have anything in place?
You mean like if we get a critical report through the bug bounty program?
Yes.
So we would obviously just assess that within our team, and then if deemed valid, we would start communicating with client teams, communicating with, as I mentioned, all the layer 2s that are using Ethereum as well, and we would have like a incident response internally. We would contact CL911 to have some kind of guidance from them as well. They're experienced in these kind of critical cases, so they're always like could be helpful for their insights. Then we would proceed to the fix and then just make a release. I don't know if in that case we would disclose it because it's super critical. I don't think we would, but there might be a specific protocol. I'm not aware of that. I'm sure if this were to happen, our team lead would just put up like a crisis, like war room, and just let us know what is the protocol to follow. And then in regards to the bounty, at the moment it's only 250K, but if it was a super critical bug, I'm sure they would be making an exception. But as I said, we're looking to bump that number up. We have other protocols that have much bigger bounties for critical, and we think that Ethereum should also have a big bounty, not just 250K, especially if you consider just destroying Ethereum as a whole. So yeah, this would be what we would do. And then after that, I don't know, we would just probably make some kind of post-mortem investigation, how we missed that, what we could learn from that mistake, and communicate on X or different various social networks.
But would you be able to disseminate the code to enough nodes without, I don't know, some attacker finding out too soon?
Sorry, could you repeat your question?
Would you be able to disseminate the code to enough nodes without disclosing what the issue is?
So we would have to make a new release in every client. But obviously, like having a critical means we have a bug in every client. So it is pretty tough now that we have some kind of good client diversity. I think it could still be improved. But yeah, we could definitely just reach all the bugs in all the clients. So the client teams know their codes like the back of their mind. So if we find the issue and if it's been disclosed to us for the bug bounty program of a easily like code path to follow, we could just send that to the different teams. They would investigate, make a fix pretty quickly, and then just make a release. Then we would advise everyone to bump to that release, and a few weeks later they would announce, oh, there's been a critical in X release, and then hopefully by the time enough nodes would have been upgraded to the new version.
Thank you.
Thank you very much. My question is more high level. I work in this field before actually starting Sator. I worked very much. I don't know if you know about consensus formal verification. And actually, it's actually one of the problems that in computer science we have a good understanding, including a system that I put, but others, for formal verification of consensus. And also in the practical side, in the system community, people have identified the bugs in the consensus. And what you are doing is actually interesting because there's staking, there's actually things that make it more amenable to bugs. So can you comment why these methods are not useful for you, or is it just a matter of priority?
I think these methods are useful. We have some kind of track, which is the formal verification ZKVM project. I think we're also funding a part of that. I'm not 100% certain, but we want to move to...
But ZKVM is proving things which is great on the implementation level.
Yeah.
But we have been seeing in the... Are you familiar with Ziziva?
No, I'm not familiar. Could you remind me on that?
So Ziziva is very interesting. I didn't know, but it's the last word in the English alphabet. Okay, and the issue that somebody actually said that he has this protocol which is right, and actually, so I'm talking about there are different level of bugs. That bugs in the implementation that you can use tools, including ZKVM and others, but bugs at the conceptual level, at the design, people have had. And there actually it's a bit simpler because you're not reasoning about the implementation, you are reasoning about the design.
Okay.
And it's actually related. We work with our client, and sometimes we see that part of the problem is that people it's not even a bug, people misunderstand the behavior of the consensus. And therefore, when they're writing, for example, you mentioned this beautiful separation between bugs in smart contract and bugs in, but we have bugs that are crossing.
Yeah.
You've seen them? Bugs that are between the smart contract and the consensus.
No, I haven't seen such type of bugs. But
in the Pepe, others,
we have, it could be a bug in the specification, as you mentioned, not directly in the implementation. But then how would, could you give him the mic, please? I want to ask him a question. How would a formal verification help in finding bugs in the specifications?
It's not finding a bug in the specification, finding bug in the model, in the design. Like you have a design of the algorithm. You write a design of the algorithm in our system IV or in TLA or in some other system, and then you reason about the design, not the implementation. So you have some kind of high-level description of the algorithm,
okay,
and you are finding a bug in. Of course, once this high level is correct, there's still another question which is hard, is that you can have an implementation bug. But we have seen in the literature, and also even Google reported that there were bugs in the design of the algorithms, which were usually identified something between 5 to 15 years after that. So you want to find these bugs before the implementation.
Yeah, definitely. So what was the original question? Sorry.
Why is it not used? But you're saying it's...
Oh, it's not used because it's a lengthy process, I would say. I would also say it's a very niche field, so we have not that much experts in formal verification. Sortora is definitely amplifying that, and you have a lot of very good formal verification engineers. But usually to do formal verification, it requires an immense amount of knowledge and a specialization. So it's a very lengthy process. It's very costful, and talents are very niche to find. And I do not think that this is the priority of the EF at the moment.
Makes sense. Thank you. The next question is about testing. So you have a beautiful system that you have sort of different level of consensus, and you are doing fuzzing, which is great. Are you actually, and maybe I didn't understand your talk, are you comparing the different implementation? Because this way you are doing it. So in the fuzzing, are you running, I forgot how it's called, Lighthouse against Prism?
Yeah.
Are you doing this?
Yes, we are doing this via fuzzing. This is called differential fuzzing. Actually, Justin wrote a differential fuzzing framework, which allows to fuzz different implementations in Java, NIM, Rust, and then other languages. And so, as I said, we are comparing the results of an execution in Java for the same function, for the same implementation in another language, and then comparing those two results to see if there's any discrepancies. And then we would find a bug. That would mean that one of the implementation is wrong, and we would have to investigate what is wrong in the function, what is wrong, is there something wrong in the specification, or something wrong elsewhere in general.
And did you already find such bugs?
I haven't personally found bugs, but I know that the EF has found some bugs, yeah.
Okay. Thank you. There are more questions.
Hello. So, like, I heard Vitalik talking about ZK and ZK being the new stuff. So, what is EF doing about the upcoming push of zero knowledge being used by top protocols in the space, even by Ethereum Foundation?
So it's not my scope of work, but what I know is that, yeah, we're pushing towards ZK EVM. We think that is very important for proving time. We want to just reduce and improve Ethereum performance overall. We want to scale Ethereum. And this is also part of the 1 trillion security project. We want to have a lot of funds on chain, and to do that, we need to make Ethereum faster. We also are funding. We're making some kind of donations to the ZK EVM formal verification track. So this is designed to formally verify ZK EVM implementations, such as RISC 0, for example, or RISC 5, I forgot. And then we have some specialists of ZK within our cryptography team, which are constantly working on that. We also have researchers trying to just write papers, work on new EIPs to push towards, ZK for Ethereum. Does anybody else has another question?
You were talking a lot about fuzzing. What about non-finality? For example, I know it is tested during the devnets and testnets, but when the clients go to mainnet and they release updates, can it happen? Like, for example, non-finality. Do you monitor it? Is it possible vector of attack?
Like, you mean that the Ethereum chain doesn't reach finality?
Yes.
Well, finality, at least to my knowledge, I'm not a CL expert, but to finality, to reach finality, we need more than 66% of the network, like validators being up. We of course test it on devnets, and we try to recover if we are not reaching finality. And this we have always been able to recover, to my knowledge, but this hasn't happened on mainnet yet. No.
Do you monitor clients updates as well? For example, like a red flag client update, or not?
Could you be more specific as to what should we monitor?
I mean, can it cause any issues when the client releases new update?
What issues do you have in mind that it could cause?
Let's say to majority clients released a malicious update, and it's like already majority, like 66%, for example. And
well, thanks to client diversity, we don't have like a client being big enough to have this kind of issue happen.
what
but
about Haleski incident?
Sorry?
Haleski incident.
Haleski? Haleski has been downed now, I think, like last month, but I wouldn't know the specifics of that, sorry.
Okay, thanks.
Does anybody else have another question? Okay. Well, thank you all for attending. I'll just give back the mic to Muli.
Thank you very much, Antoine, for the presentation. Maybe you can also share with us information here if you have, but we want to learn more. I think Antoine actually mentioned that the zero knowledge, so we have a little break, but after that, Jeffrey from the Rare Skills will actually, is going to do the presentation of zero